Hey guys, so today we're going to be tackling some of these organic chemistry problems. The first one says, species that have the same number of electrons are described as isoelectronic. What +1 element is isoelectronic with magnesium with a +2 charge? We can look at the periodic table and we see that magnesium has an atomic number of 12. That means as a neutral uncharged atom, it has 12 electrons. However, our ion has a +2 charge, which means it's missing 2 electrons to help balance out with the protons. So in total, our magnesium ion only has 10 electrons. Now that we know we have 10 electrons, we need to find a +1 charged element that is isoelectronic with 10 electrons. All we need to do is find an element with 11 electrons in its neutral state. We know this will work because if you have an element with 11 electrons and it loses one, it'll gain a +1 charge and it'll have 10 total electrons, and that's exactly what we're looking for. So let's locate atomic number 11, and that turns out to be sodium. So our first answer is sodium. So this second question is going to be very similar. We're asked, which of the following ions possess a noble gas electron configuration? And we're given the options: potassium with a +1 charge, we have hydrogen with a -1 charge, we have fluorine with a -1 charge, we have helium with a +1 charge, and we have oxygen, and finally calcium with a +2 charge. So to solve this, let's find the number of electrons in the noble gases, which is in this section here of the periodic table. So we have helium, neon, argon, krypton, xenon, and this has kind of become our key. We have helium at 2 electrons, we have neon at 10, we have argon at 18, we have krypton at 36, we have xenon at 54, and there are a couple more, but we're not going to need to worry about those for this problem. So let's take a look at our first ion and see if it has the same number of electrons as any of these noble gases. Our first ion is potassium with a +1 charge. Potassium as an element has 19 electrons, but with this +1 charge, we're going to be taking away an electron, so that makes 18. Now let's see if we have 18 on this list. It's actually isoelectronic with argon, so that does fit. Now let's take a look at hydrogen. Hydrogen normally has 1 electron, but with a -1 charge, it's going to gain an electron. So we have 2 total electrons. And let's see, that looks like it's isoelectronic with helium here. So hydrogen ion fits. Now let's take a look at fluorine. Fluorine has 9 electrons. But again, we have this -1 charge, so it has a total of 10 electrons. Let's go down the list. It looks like it's isoelectronic with neon, so that one fits. Here's helium. Helium normally has 2 electrons, but it has a +1 charge, so we're going to lose an electron, and that's going to become 1 total electron. Now if we look on this list, there is not a 1, so that means helium does not fit. Helium itself is actually a noble gas, so any charge on helium would mean it would not fit. Now for oxygen, elemental oxygen here, this is not an ion, this is just an atom, has an atomic number of 8. And so that means there's 8 electrons in this oxygen atom, and it doesn't appear to have a charge, so our final answer is actually 8. I don't see 8 on here, and oxygen is not a noble gas, so this one does not fit. Now calcium. A calcium atom has 20 electrons, but we see we have a +2 charge here, so we're going to be losing 2 electrons, and that means we get 18 total electrons. I see 18 is isoelectronic with argon, so that fits. So our winners here are going to be this potassium ion, this hydrogen ion, this fluorine ion, and this calcium ion. So I believe that comes out to A, B, C, and F. And so that is our final answer right there. Now for this third question, we're asked to draw both dot and line Lewis structures for propane, methanol, and ethene. So I'm going to show you guys how to draw these 3 molecules in both dot and line Lewis forms. So let's start with propane. Propane's molecular formula is C3H8 because it's an alkane. So that means we're going to start with the 3 carbons here as sort of a backbone. We have 1, 2, 3 carbons. And now we have 8 hydrogens. And so every carbon is going to have 4 total bonds coming off of it. So let's just fill out the first carbon. So you see it has 1, 2, 3, 4 total bonds. Let's fill out the rest of this carbon, 1, 2, 3, 4 for that carbon. And for this final carbon, 1, 2, 3, 4. And now we can fill out the hydrogens. And you see we have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So that is the first way to draw it. And the second way is very similar, but instead of using lines to represent these bonds, we're going to use dots. So again, we're going to start with 1, 2, 3 carbons, and these dots represent electrons, or the shared electrons that form a bond. And we're going to want to fill out the first carbon, 1, 2, 3, 4 bonds. We can plop those first hydrogens in there. And I'm just going to complete all of these bonds. One, 2, 3, 4, 5, 6, 7, 8 hydrogens. It's right over here. And that's how you draw propane in both line and dot structures. Alright, our next molecule is going to be methanol, and methanol has the molecular formula CH3OH. And I'm going to first start with the line structure of this. We're going to have a carbon. We usually start with carbons. It's a good backbone to start off of. And remember, carbons have 1, 2, 3, 4 bonds coming off of it. We're going to fill out 3 of these bonds because we have CH3 with our hydrogens. And so we have 1, 2, 3 hydrogens. We've completed the first little part of the molecule. And now we have this OH. So we're going to connect our O, our oxygen, and our hydrogen coming off of that. Methanol is an alcohol, so it has this hydroxy group right here. Now we're not quite finished. Our oxygen is actually going to have 2 lone pairs coming off of it. So that's how you draw lone pairs. Oxygen has 2 lone pairs and 2 bonds. So we're done with our line structure. Now a dot structure, we're just going to be replacing all of our line bonds with a pair of dots. So we're going to draw the same thing. We're going to have 1, 2, 3 hydrogens. We're going to have our oxygen. Don't forget those 1, 2, 3, 4 lone pairs, or I guess 2 lone pairs with 4 total electrons, and 1 more bond made of dots, and that is our methanol. Now our next molecule is ethene. Ethene has the molecular formula C2H4. Ethene is an alkene, and alkenes have double bonds between the carbons. So let's draw a carbon with a double bond. And we have 4 hydrogens, and because carbons need 4 bonds coming off of them, and this one already has 2, we're only going to draw 1, 2 bonds. 1, 2 bonds coming off of these carbons. So we have 1, 2, 3, 4 total bonds around these carbons. And now for the 4 hydrogens, we're just going to fill out these empty spaces with hydrogens, and that's our line formula for ethene. Now for dots, this is going to look very similar. We're going to have 1, 2 carbons, and these double bonds are actually represented by 1, 2, 3, 4 dots instead of just 2. Your standard bonds. And we're going to replace those other lines with dots. 1, 2, 3, 1, 2, 3, 4 hydrogens, 2 carbons, 1, 2, 4 hydrogens, 1, 2, 3, 4. And that's ethene. I hope you guys found this video helpful, and comment down below if you have any questions.